Okay, there were two problems that I didn't get to because they just take so long. So I'm gonna do those. This will be the fourth section of the Unit 5 study guide. So for the YouTube video, this will be the fourth section. So just gives you an idea of how much we covered in Unit 5, really. There's 4 videos for the study guide. But anyway, here we go. This is from lesson 17. So it says the feathers in a pillow have a total mass of 59 grams. I encourage you to call a timeout and write that. So you're gonna say mass equals 59 grams, okay? Because your brain can only handle so much at a time. So that's the key piece of information. The pillow is in the shape of a rectangular prism, okay? So it's a pillow in the shape of a rectangular prism. Alrighty. There's a rectangular prism. Okie doke. The measurements are 66 by 51 by 7. Meaning, right away, you know that your volume is 66 times 51 times 7. Because that's length, width, height, right? And they're all interchangeable because multiplication is communicative. But you just go 65 times 51 times 7. So you'll find a volume of 23,562. Now this is really important. These are centimeters. So you're gonna say cubic centimeters. And that is a critical piece of information. So we're gonna put a box around it. This is a critical piece of information. So use different colors to make your work emphasize the key points. Okay. Now, a steel anchor. Let's go over here for the steel anchor. I've seen a lot of these if you ever fish. I'm not much of a fisherman. I mean, it's my name, but it really should be better. My last name is Fisher, but anyway, you got a steel anchor over here. And the reason I know the shape is because I've already seen this problem. But a steel anchor is shaped like a square pyramid. Okay, so a pyramid, the base is a square, and then it has an apex. So you just draw a parallelogram, and then you connect every one of these points to your apex, which you just kind of draw. You don't have to have a perfect apex location. But anyway, square pyramid. Okay, steel anchor, square pyramid. Each side of the base measures 20 centimeters. That means this is 20 and this is 20. What else does that mean? Well, that means your base, the area of the base, is 400. That's important. Okay, so we're right here. And the height, so the height of this steel anchor right up here is 28. Okay? Your mass, we'll just write it right here, is 30 kilograms. So when you get these questions that are intense like this, you gotta kind of compartmentalize your thinking by writing everything down, and then you make sure you get all the key information, and then you start to attack the problem. Now, we're gonna get into volume. You just know that's coming. So compute the volume of the pyramid. Base height over 3. There's your volume for all the pyramids. Now, your base was 400, so volume equals 400. Your height is 28, and you got to divide that by 3. So let's just do that real quick. 400 times 28 divided by 3 is 3733.33. That's your volume, and that's going to be in cubic centimeters. So your volume will be in cubic centimeters. Okay. All right, let's review what we just worked on. We've got our mass, we've got our volume, steel anchor. We've got our mass, we've got our volume for the pillow. All right, this is a pillow, believe it or not. Okay, what's the density of feathers? Density of feathers in kilograms per cubic meter. Let's go ahead and rewrite what we know. Mass equals 59 grams. Volume equals 23,562 cubic centimeters. Okay? This stuff is given by this, because we did the work already. Now, they're asking us, though, check this out. Density of feathers in kilograms, we're in grams. Per cubic meter, we're in centimeters. So you have to do a conversion. You have to convert grams to kilograms and cubic centimeters to cubic meters. You have to do that first. So let's do that. 59 grams. How could you get 59 grams into kilograms? Well, you need to know the conversions. Like, what does a kilogram equal? Well, 1 kilogram is the same thing as 1,000 grams. Okay? So 1 kilogram is the same as 1,000 grams. Now, we have a mass of 59 grams. And we have to figure out how many kilograms that is. So you use your old friend's cross multiplication. 59 times 1 is 59. X times 1,000 is 1,000x. Divide by 1,000. Divide by 1,000. Cross that out. X equals 0.059. So X equals 0.059. 59 divided by 1, 2. Wait, let me clear it out. 59 divided by 1, 2, 3 zeros. Okay, 0.059 kilograms. All right, so box that up. You've got your mass, but in kilograms now. So it's 59 grams or 0.059 kilograms. All right, cool. Now you also have to convert the volume because we're in cubic centimeters. So we now have to convert that to cubic meters, which means you need to know how many cubic centimeters are in 1 cubic meter. And that information I'm going to give to you. So let's just like segment our little, or compartmentalize our work so you know what's what. 1 cubic meter is the same as 1 million cubic centimeters. So you're just going to set a fraction over on the right and then write this in. So if the cubic centimeters are on the bottom, you put this one on the bottom. And then we got to solve for x. Cross multiply. These are super important concepts. Cross multiplication, you have a fraction that equals a fraction. All you got to do is cross multiply to simplify. X times 1,000,000 is 1,000,000 x, and that'll equal 23562 times 1 is just going to be 23,562. We'll worry about the units later. Divide this by 1,000,000. Divide this by 1,000,000. Cross that out. X will equal 23,562. 23562 divided by 1,000,000. 1, 2, 3, 1, 2, 3, 6 zeros. And you will get 0.02356. And what do you do with that? Well, you know it's up here. That's going to be cubic meters. So that's the same as 0.02356 cubic meters. So 59 grams is 0.059 kilograms. 23,562 cubic centimeters is 0.023562 cubic meters. Now you can finally answer this question, which is brutal. They just threw a little trick in there for you. So what's the density of feathers in kilograms per cubic meter? So you got to go kilograms over cubic meter. And for this, it is 0.059 divided by 0.02356. That'll give you your answer. 0.059 divided by 0.023562. Hit equals. You are going to get the kilograms per cubic meter equals 2.504031916. Did they give you? I'm just going to say 2.5. So kilograms per cubic meter, 2.5. Woo! Question 1 is done. All right. Number 2. What is the density of steel in kilograms per cubic meter? Okay. Let's take a look at what we have here. Well, mass equals 30 kilograms. Sweet. They asked us kilograms. Cool. Volume equals 3733.33 cubic centimeters. They asked for cubic meters, those punks. So we got to do this conversion again right here. So here we go. 1 over 1,000,000. Remember, a cubic meter has 1,000,000 is the same thing as 1,000,000 cubic centimeters. So you got to go 1. If you want to write it again, that's not a bad idea, so you don't lose your train of thought. And then you got to write in cubic centimeters down on the bottom. 3733.33. You throw an X right there. Then you cross multiply. So 3733.33 times 1 is 3733.33. That'll equal 1 million x. Then you divide by a million. Divide by a million. These are out of here. You're gonna get this answer right here. X will equal this divided by this. So let's do that. 3733.33 divided by 1 million. 123 equals 0.003733. You might as well keep going with the threes. All right. That is your cubic meters. So now you have your kilograms, you have your cubic meters. Your final answer, I'm going to draw a little arrow over here, is going to be 30 kilograms per 0.00373333 cubic meters. That is what the question's asking. What is the density of steel in kilograms per cubic meter? And your final answer will be 30 divided by 0.00373333 equals 8035.72146. So let's just round that to the nearest. So you're going to say 8,036 kilograms per cubic meter. And that is your final answer. This is your last thing to box. That's your answer. Oh my gosh, I actually ran out of ink. Isn't that crazy? Finally ran out of red ink. Wow, this thing's been used a lot. Nice job, teaching assistants. All right, gotta get another one. Okay, so what's the volume of 1,000 kilograms of feathers in cubic meters? So we need our answer to number 1 to get this. So where's our answer? Geez, well, it's right here. If you know that 2.5 kilograms are in every single cubic meter, then what will 1,000 kilograms be in cubic meters? That's going to be X right here. Got a little bit of ink left, maybe. Cross multiply. X times 2.5 is 2.5x equals 1,000. Got to divide by 2.5, divide by 2.5. These are out of here. Your final answer is going to be 1,000 divided by 2.5, which equals 400. So x equals 400. Now, you have this x equals 400. Now let's rewrite it. Let's just answer the question in sentence form. So you will say the volume of 1,000 kilograms is 400 cubic meters. Yay, we got it. Okay, number 4. 3 is done. What's the volume of 1,000 kilograms of steel in cubic meters? Well, we know from here that 8,036 kilograms are in every single 1 cubic meter. That's what we've learned from our previous work. Now they're asking you, what about 1,000 kilograms? What will that equal in cubic meters? One more cross multiplication. That might be the official end of my red pen. So 8,036 times x equals 1,000. Divide both by 8,036. Divide by 8,036. That's out of here. X equals 1,000 divided by 36. X equals 0.12. And we'll just keep it there with rounding. So let's write that. The volume of 1,000 kilograms of steel is 0.12 cubic meters. Meaning, and I'll box this one up, that 1,000 kilograms of feathers will take up 400 cubic meters of like airspace. However, 1,000 kilograms of steel will only take up 0.12 cubic meters of airspace. How much bigger is 400 than 0.12? Well, let's just find out. 400 divided by 0.12. About 3,333 times the amount of airspace for feathers. So feathers are gonna, 1,000 kilograms of feathers is gonna take up like the whole third floor hallway. But 1,000 kilograms of steel is barely gonna take up any space. And that's why density is so important, because density equals mass divided by volume. Now I'm gonna zoom out as much as I can on this, and I'm gonna show you something. Hopefully it doesn't break my desk. See this dumbbell that weighs 45 pounds? Well, I would argue that the dumbbell and my basketball, this Spalding basketball right here, the dumbbell and the basketball have about the same volume. Like they take up about the same amount of airspace. But can I like roll a dumbbell as easily as I can roll this basketball? No, because this thing is so dense. So a 45-pound dumbbell is way more dense than this basketball, even though they have about the same volume or like total airspace they take up. So that's what that problem is teaching you. Density. Mass divided by volume. All right. That was a 20-minute problem. Yeehaw. We got one more long one, and I got a meeting in 8 minutes. All right. Here we go. Brutal problem. If you can do this one, you're gonna be fine on the test. It's a tough problem, very tough problem, but it teaches you a lot. That's why I like it. Tough problems are more fun than easy ones. Okay, this was the second one that would have taken too much class time. Typically, class time is about double or triple what it takes for me to work them out on these videos, just me. So if I would have done this problem in class, that would have been like pretty much the whole class. And I don't want to do that because there's so many concepts that you got to get for Unit 5. So I prefer to do them on the video. This is another one. It's not as long as that last one, but it's pretty dang long. There's a lot of work to do. So they say select all the solids that have a volume of 40 cubic units. Okie doke. Rectangular prism, volume, length times width times height. And because multiplication is communicative, you can do any order for the multiplication. So let's just go 4 times 5 times 2. 4 times 5 is 20 times 2 is 40. That is 40. Circle it. Right rectangular pyramid. Well, volume is always going to be base height divided by 3 because it has what's called an apex. So, you got a shark over here, right? He's a happy shark, I guess. Maybe I can make him mean. Nah, you got a shark. That's an apex predator, right? Apex means top. Okay, so anyway, if it's got an apex, like the apex predator shark, you know it's got a top point. If it's got a top point, it's base height over 3. All right, so the base is 4 times 2. The height is 5, and then you got to divide that by 3. Base, 4 times 2, it's a rectangle. Height is 5. So 4 times 2 times 5 divided by 3. We all know 4 times 2 times 5 is 40. So this one's going to be 40 divided by 3. So this is no-go. That's not 40. Right? Okay, let me zoom in again. I zoomed out. I forgot to zoom back in. Little things, Fisher. Okay. Right hexagonal prism. Again, apex. This guy. Apex. That means your volume is base height divided by 3. So volume, base is 15. Height is 8. And then we divide that by 3. 15 times 8, 80 plus 40 is 120. I don't know if you noticed that, but 8 times 10 is 80. 8 times 5 is 40. So 80 plus 40 is 120. 120 divided by 3 is 40. Hey, that's what we're looking for. So that one you circle. All right, let's go triangular pyramid. Here's your shark, right? Apex. Apex predators. The top of the food chain, right? All right, so we've got a triangular pyramid. And that means that we got to compute the area of a triangle, which is, and this is a right triangle, which makes it a little easier. The area of any triangle is 1/2 base times height. That's the base, that's the height. So it's 1/2 4 times 5, which equals 1/2 of 20, which equals 10. So your area of this puppy is 10. Now, I had a battle with somebody that said, isn't it 1/2 length times width? Yeah, but that L times W only applies to right triangles. Somebody taught you 1/2 L times W. Well, that's for right triangles. Yep, that would work. But this one, 1/2 little b, little h, works for all triangles. And that's why I prefer going 1/2 little b, little h, because it applies to all triangles. I know. We could have a debate for days over that. Because some people would be like, well, that is confusing, because like now I don't know what's b and what's h. Well, it's not that hard. All right, so the volume of a triangular pyramid is V equals, here it comes, BH divided by 3. Different B than that, different H than that. That's just for the triangle. So I see where people would make the argument this is easier. But wouldn't you want a formula that applies to all triangles? Anyway, we'll talk more about that later. All right, so our base is the same thing as the area. So this base is 10. We already figured it out. So the base is 10. So 10, what's the height? It's 12. That's given right here. It's the length of the apex down to the base, making a right angle. Okay, so 10 times 12 divided by 3 is 120 divided by 3, and that's 40. That one's in. All right, what is this? Is that a pie? Please tell me that's not a pie. It probably is, huh? Is that really pie? Let me check. 14, practice problem 3, page 310. Yeah, I'll teach you how to use these 310. So if you lose your study guide, you know where to go. That is a pie. Oh my goodness. Okay, here we go. If you lose your study guide, this thing's on Google Classroom, so you could print it out, or you could just look at it digitally and then go to your workbook. 310. All right, here we go. A cylinder. right? Circular bases that are congruent, translated from the top to bottom by the height. So anyway, this is your radius, this is your height. So just look at the figure and dissect it before you like launch into these problems. It'll make it easier. Go slow. Like, I know I'm going fast in this video, but geometry cannot be rushed. So your volume of a cylinder is pi r squared times height, or in other words, base times height. There's no apex, so it's just base times height. The base is a circle, so it's pi r squared times height. So all you gotta do is rewrite your formula and then plug and play. So pi, radius is 2, square it, times your height, which is 10 over pi. All right, throwing some difficult numbers in, no big deal. 2 times 2 is 4 pi times 10 over pi. Now, with multiplications of fractions, you just do the top times the bottom. So 40 pi, 1 times pi is just pi. These are out. So there it is, 40. This one's in the club. All right, I got 1 minute, and then I gotta go. Right hexagonal prism. Is there an apex? Is there a shark anywhere cruising around? Nope, there's no apex, so the shark's not applying. So for that, it's just volume equals base times height. Why? Because there's no apex predator lurking. There's no apex predator lurking. So it's just base times height. And so you're given the base, which is 30. So 30 times your height, which is 4. 30 times 4 is 120. They're trying to trick you on this, because some people will be like, wait a second, divided that by 3, it's 40. I'm going to circle that one. Nope. Do not circle this one, because this one's just 120. Because there's no apex, no predator lurking. All right, 32 minutes for 2 of the final 2 problems that I didn't cover in class. Ask yourself which works better for you. Do you like the classroom live video, or do you like my personal page? I don't know which one I like better. This probably moves too fast, the way I did it this way, and in class I go a little slower for a reason, because I don't want to lose people. So in geometry, like chess, there's no need to rush. Take your time. Unless, of course, you have a timer, like chess. All right.